Yeah, this slide, that this is all we have already understood. You can see now that this is the present arrangement of plates here. Okay, here you can easily see that the plate tectonics which we were discussing, now the continents and the oceanic areas, they cannot be, you can see they cannot be divided like this and this. Actually, they can be divided along these plate boundaries. Okay, so here you can see that this is the mid-Atlantic ridge part, this part. So, I think this. Yeah. So this is your along this. This is the mid-Atlantic ridge. Okay, this is the most striking feature here. Mid-Atlantic ridge. What is happening here? This is the diverging boundary that we were discussing. Diverging boundary means below this, the plates would be moving. Means the currents, convectional currents, would be moving in this manner. So that is why these two plates, there is a rift, this rift, and these two plates are moving away from each other in this manner. Okay. So initially, the Pangea was like this, means this part and this part, they were here, and there was no Atlantic Ocean. Means through this theory, you can understand the formation of continents and oceanic floors here. In the first class, you were asking that, sir, what is the theory of continents and oceanic floor origin? So this is the theory. Means initially there was a proto-continent, Pangea, and it was surrounded by a proto-ocean, Panthalassa. Okay. Then what occurred due to Earth's internal forces? That proto-continent, yeah, that was broken into many present-day continents. So in this manner, when there was a rift, and this part of the continent and this part of the continent, they moved away from each other, the oceanic floor came into existence in that manner. There was no ocean between them. This part was here and this part was here. They were jetted together. Later on, when they were moving in this manner, that the means the you can say that later on the width of the continent like this. When they moved in such a manner, okay, and between them there originated a new floor. This was made up of basalt. This oceanic floor is made up of largely of basalt, and the continents which were moving apart from each other, they are made up of granite. This is granite, and this new floor. And this new floor is not so wide as continents are. Why? Because it has more density. And for isostatic balance, that I had already discussed in the isostacy topic, for isostatic balance, if they are more dense, they have to be less wide. Okay. For more density, they have to less wide so as to balance them with the alongside continents. That is why oceanic floor is not so much wide. Okay. That is why it looks like a basin. Means these areas and these areas are high and this area is low. That is why it looks like a basin. Later on, water came because of climatic factors, because of because of volcanic eruptions, and water filled in that basin area. As they were moving apart, as continents were moving apart from each other, those oceanic floor were being widened and widened, and new water was filled up there, and in that way these oceanic areas originated, and the present day continents also originated, you can say. Okay. So in this map, you can see that this is North American plate. This whole is North American plate. Okay. This whole is North American plate, means all the North America and this western part of Atlantic Ocean. Means here the plate is continental as well as oceanic. Continental plus oceanic. Likewise here Eurasian plate is also oceanic. This part is oceanic and this is continental. है ना? Come here. Like this South American plate, continental part, this is oceanic part. Like this African plate, oceanic part and continental part. You can see here. There is also means there is a division of major plates and minor plates. What is that division? Major plate means a plate having major amount of seismicity in its boundaries. You can say that a plate, if it has a major amount of seismicity in its boundaries, historical evidences of seismicity, it can be said a major plate. Within that major plate, there is smaller amounts of seismicity along some boundaries. So those boundaries like this, like there is some evidences of seismicity here. And in that way, this is a minor Arabian plate. Okay, though this is part of this African plate. Okay, but this is a minor plate. Like this part is Indian plate is a minor plate, but it is part of this major Australian plate. Australian plate is a major plate, and Indian plate is a part of that plate. Yeah. Antarctic plate. Indian plate, the largest part is oceanic. Yeah. Indian plate is also a continental and oceanic, both type of plate. Most of the plates are like this. They have continental and oceanic both parts. Means continents and oceans both are moving with each other. It is not that Wegener said that continents are moving over the oceans like a boat. Okay, they are moving with each other. And the driving force is coming in the mid-oceanic areas. Driving force is coming from the mid-oceanic areas. Actually, all the collision is happening also because of this mid-oceanic seafloor spreading. Means here, if there is a collision, here you can say that there is a collision. Two plates are colliding with each other. Okay, here there is a collision. This Pacific plate and this Australian plate are colliding with each other. But where is the driving mechanism, driving boundary? This driving boundary is here, you can say. If along this side, along this ridge area, this mid-oceanic ridge, the plate is moving in this manner. Divergent. So because of this divergence, this convergence is happening. Means the driving force is coming in the mid-oceanic areas. That have to be understood. The mechanism have to be understood in such a manner. Okay. So this is also a minor plate, Caribbean plate, Nazca plate, okay, Cocos plate, Juan de Fuca plate, Filipino plate. They are all minor plates. Scotia plate, minor plate. These smaller plates are minor plates. So you have to understand this plate diagram first. What is the division of the plates in the whole Earth? Okay, so this is a major plate of North America, major plate of South America, two major plate of Eurasian plate, major plate of African plate, four plate. Okay, one southern plate is Antarctic plate, five. Then one more plate is Indo-Australian plate. This is also a major plate. Then one more plate is Pacific plate. You can easily see that Pacific plate is the only plate which is whole oceanic. All the Pacific plate is largely oceanic. It has no continental part. This could be asked in your prelims. Okay, which of the plate is totally oceanic? Okay, so you can easily see that Pacific plate is largely oceanic plate. All other plates have oceanic as well as continental parts, right? So now come to these diagrams. Like this is we'll start with first diverging boundary. Okay, first diverging boundary. Diverging boundary is nothing but the mid-oceanic areas, mid-oceanic rift areas. Like you can see here also like this. This is a color yellow. Yeah. So this boundary in 3D, this is a 3D figure. This boundary is a diverging boundary. Divergence is happening in this manner. You can see, you can understand that here from convectional currents would be rising in this manner, their direction. They will go, and because of this direction of convectional currents, plates are moving away from each other here. So in this mid-oceanic part, there will arise this magma. Magma will come out of this rift, and this will be accumulated here in this manner. Later on, with the movement of the plate, this magma will be coming here, 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 and it will be spreading in this manner. Means the older magma you will find here, away from the oceanic area, away from the mid-rift area. The magma which is found here is younger because the older magma will move here, 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 here. Okay, and this is what the Harry Hess observation. He saw that here the magma is older, so he could study. He could conclude that the older magma, why it is older, because previously it was here and then it has moved here, and here means as he was moving away from these rift areas, the magma was going older and older, means its age. Okay, and he could also see the polarity of the crystals. He could see that the after a particular distance, the polarity is being reversed. There is a reversal of polarity, north, south, or reversed. So he could see the bands, particular bands here on both sides of the mid-oceanic rift areas. So seeing these bands, alternate bands of polarity, he could decipher that earlier this part of the continent and this part of the continent were jutted together. Then new magma came and they are moving like this. Okay, so along these diverging boundaries, we are studying landforms only in geomorphology. So along these diverging boundaries, what are the landforms which are being made? First, there is a rift. You can see that there is a rift crack. So this is called mid-oceanic rift. Then along this rift, there is such a formation. And this formation is known as ridge. Rift is just a crack along which new magma is always coming out. Just a crack means this middle part. This middle part is rift, and the whole structure is called the ridge. This is what means if this is a plain part, some part has been raised in this manner. This is called ridge. You can see such type of ridge example in Delhi ridge area. Okay, in North Campus area, FDU, you can see such type of ridges. Okay, and in most of the time, such types of ridges are made by either igneous or metamorphic rocks. Why? Because these rocks are harder rocks. Only a hard rock can make such type of ridge, but it is not always possible that always hard rocks will make ridges. Even soft rock can make ridges, but with a particular climate, means climatic difference. Like in arid climates, even softer rocks like calcium carbonate, which might be soluble in humid climate, that can make a ridge. Means in the formation of a particular landform, not only structure or rock type plays a role, also a role is played by the climate. Okay, so that is why Davis said that a landform is the result of structure, process, and time. These are three factors which make a particular landform. The structure, process. By process, he means not only endogenetic and exogenetic processes, also the climate. So that is why it is called the climate process system. The second factor is known as, first factor is structure, rock type. Second factor is climate process system, means the endogenetic processes and the exogenetic processes in combination with the particular climate where the rock is found. Okay, they make the particular landform, and that also need a time. Means for making a particular landform, a particular time span is required. Okay, so this ridge is not formed in a single year or in 10 years or 100 years. That can require thousands of years for its formation. Okay, so initially there was only a crack, a rift. Later on, later on means in thousands of years, as magma is being accumulated along these rift areas, such type of ridge structure. What about? What about ocean basin? Yeah, oceanic basins, as I had already said, that oceanic basins are the result of this seafloor spreading mechanism. Means there was no Atlantic Ocean previously between North America and European continent, between South America and African continent. There was no Atlantic Ocean. Then what happened? There happened a crack between these continents. Okay. Then what happened? That crack widened in the form of oceanic basin. So in the plate tectonic manner, as continents went apart from each other, that oceanic basin came into existence. Yeah, oceanic crust. Actually, oceanic basin is what? This oceanic crust. This part, which is coming out. All this oceanic crust actually came out from here in the form of magma. That is why it is made up of basalt. Basalt are the result of this. Yeah, one more. This, how the climate would be endogenetic. In the climate process for formation of landform. Actually, climate is not endogenetic. Climate is not endogenetic. Endogenetic is the process. Means I was saying that. Yeah. Yeah, endogenic is inside. Means the forces which are coming from within the earth, they are endogenetic. Means if a particular process, I was saying only that a particular process, it might be endogenetic, means coming from within the earth, or it might be exogenetic, outside the earth, like it might be made by river, wind, or weathering. So that processes plus the climate found there, means where the landform is being found, the climate there, they work as a system. Means the process and the climate, they work as a system with the structure. Okay, so this plus time. Yeah, convectional forces are endogenetic. They are coming from within the earth. And climate is an exogenic factor, you can say. Climate is not endogenic. Climate is exogenic factor. Okay, it is outside the earth's internal structure. Okay, so these process plus climate plus structure plus time will result a particular landform. You can see that structure is like a material. Like you have some soil and you have to make a picture. What will you do? From that soil, okay, you will make a picture with a process, following a process. Okay, but first you need some material, soil. So that material is structure. Yeah, and you can say that this is the sculptor. This is the sculptor which makes an idol. Okay, for an idol, for idol making, you need some material, you need some rock. Okay, so this is the rock, and this is the process, and with a particular time, you will make a landform. Okay, so this is the whole mechanism. Yeah, for pot making. So like that, pot making. So I was saying that along this particular diverging boundary, you can find some mid-oceanic rift and ridges. Okay, and also here are some volcanoes. Okay, in the volcano topic, we will study in detail those volcanoes and the mechanism with which those volcanoes originate. Okay, so here would be some volcanoes, some rift and ridges. Okay, then what are the landforms here along these convergent boundaries?
Convergent boundary might be ocean, crust.
Yeah, convergence. Yeah, like here you can see that convergent boundary along which collision of two plates occur, be it ocean continent, oceanic ocean, or continent continent. Means there are, one second.
Sir, send this PDF, sir.
Yeah, I will send it. Okay. Means after diverging boundary, means diverging boundary along these boundaries, along these diverging boundaries, the landforms are mid-oceanic rift, okay, mid-oceanic ridges, and volcanoes. Though these volcanoes are not so tall like normal volcanoes that you see on continents, cone-shaped, okay. Mostly silent type of eruption happens in these volcanoes.
Recently, near Japan or somewhere, new island have been emerged on.
Yeah, it is being studied. Okay.
Is it near Japan?
Yeah, somewhere nearby Japan. So such types of means rifts are like this, like crack. Along these rifts, there is ridges on both sides. Okay, so this is the rift. This is the whole structure is known as ridge. It is formed by igneous and metamorphic rocks. Okay, and in some parts you can see, means along all this rift, you can see the volcanism, feature of volcanism, and earthquakes as well. Somewhat seismicity. That is why it is a boundary. Means how will you define a particular boundary, plate boundary? Why a particular plate is plate? Because it has seismicity along its boundaries. A particular plate has seismicity, has a evidence of seismicity along its boundaries. That is why it is known as a separate plate. Okay, and its full form is lithospheric plate. It is made up of lithosphere. Okay, then come to converging boundary. Converging boundaries. As I have already discussed, that convergence might happen between two continents. Like this is a continent, this is a continent.
Ocean.
Yeah, between two oceans, or one plate could be continental and one plate could be oceanic. There are all the three conditions. Continental, continental, convergence, like these two plates are coming towards each other. And its example is, what is the example of this type of convergence? This type of convergence is happening in alongside Himalayas.
Yes.
Okay.
Eurasian.
Yeah. Like this is Indian plate and this is Eurasian plate. They are colliding with each other. And in this collision, what is happening? The sediment load between these two plates, that is being, you can say that is being converted into old mountains like this Himalayas.
So, I'll ask you, convergence of the continental ocean is subduction, right? Is it? Is she asking?
Yeah. What is asking?
Subduction.
Sir, convergence of continent with the ocean is subduction, right?
She's asking like when one ocean crust and continental crust converges. So will it form? Is that the only reason for subduction? She's asking.
Yeah. This is the only reason. Like this, I am explaining this. in this example. Like this is an oceanic floor. I'll make it like this, that this is a continental floor. Okay. This is an oceanic floor. Okay. Here they are coming towards each other. Convergence is happening. What will happen? Because this floor, actually, this floor is not wider enough. Oceanic floor, as I had already said, that this oceanic floor is not that much wide. This is like this. Yeah, because this is denser. Oceanic floor is denser. Okay. What will happen? Because it has more density. Denser. It has less density. Less density. So, you know that more dense material will go downwards, and this process is known as subduction. Subduction is just there is no chance of subduction. Like here, you can say, like here, this is a white continent of Indian continent. This is also a white continent like Eurasian continent. Can you explain the subduction mechanism here? Is there any chance of subduction here? Yeah, I'm explaining that only. Yeah, I'm explaining that doubt only. Yeah. So I'm explaining that if both the continents are, if both the plates are continental plates, there is no chance of subduction because density is same here. If here is D, here is also D. Okay. This is D, this is D. Here is what? If this is D, if this is D1, this is D2. And what is here? D1 is less than D2. Okay, because D2 means the density of the oceanic crust is more, it will go under. And this process is known as subduction. Here, there is no chance of subduction because both the plates are equally dense and equally wide also. They will only collide. And if there is some amount of sediments here, what will happen? That sediment will be folded like this, like Himalayas are the result. Right? Understood? Okay. Hem Puja. Yeah, Hem Puja. Have you understood the concept of subduction? Only the denser plate can go underneath. Yeah. So this is the mechanism along these continental and continental plates, along this continental and oceanic plate. One more example, oceanic and oceanic plate collision. I will explain here. Okay, like this is an oceanic plate. This is also an oceanic plate. Here are the chances of subduction because both the plates, though they are dense material plates, basalt, but basalt are of many types. Okay, here the density could be more, means it could be D1, it could be D2, and might be that D1 means D2 is the same condition here, like D1 is less than D2. Then what will happen? This D2 means more dense plate will go underneath, downwards. Okay, it will be coming underneath, then it will melt because here the temperature will be increased and it will come out in the form of magma. Okay, and here a new volcano would be formed inside ocean, just like the example of Japan, Indonesia, Philippines, right? All these islands, they are known as archipelago. archipelago. Archipelago or what? They are the group of islands. They are archipelago of Japan, Indonesia, Philippines. They are the result of oceanic and oceanic type of collision. Okay. Here there are no chances of there, though there is collision, but there is no subduction. Here is subduction. Here is subduction.
Sir, ocean that will diverge, sir. Will they diverge? Two ocean crusts will diverge.
Yeah, in the mid-oceanic areas, they are diverging. They are diverging, are there? But you can see that even the continental parts have, they might have diverging boundaries. Like in the Great African Rift area that I was discussing in, I think, first or second class, the East African Rift Valley. There is being made a new type of rift in the eastern part of African continent. Okay, that is part of the all the lake areas. That is known as the East African Rift Valley. Alongside that rift means East African part is like it is like this is the East African part, and here is being made a rift. Means rift can also be made. Yeah, diverging boundaries can also be found within the continents, not only within oceanic areas. Okay, in Earth's condition, there is no boundary. Yeah, valleys were due to this divergence only.
So in Himalayas, Jammu and Kashmir valleys are formed.
No. That is a different story. Here in Himalayan areas, valleys are formed mostly due to the riverine erosion, due to the erosional factors. Here, valleys are they are rift valley. Rift valley is a different type of valley. It is because of the Earth's internal endogenetic forces. Okay, like Narmada River is flowing in a rift valley. It has not cut through the valley. Actually, it has only occupied the valley. Like there was a source of a river, and the source was already in a rift valley. So just the water came out of the origin, and it started flowing in a particular direction, following the slope of the valley. Means Narmada River has not cut through its valley originally. It has only occupied the valley. It was already made through the rift system, to the internal forces. That is why Vindhyachal and Satpura are like block mountains, and between them there is a rift valley of Narmada. Right? So this is the whole mechanism. So you can easily understand these converging boundaries means like Himalayas, and you can say like Himalayas are the example of continental, or the result of continental and continental collision. Like Japan, Indonesia, and Philippines archipelago, they are the result of. They are also called island arc systems. Island arc systems, because they are found in the shape of arc. You can see Japan, Philippines, Indonesia. Arc means a particular shape of the arrangement of the islands. Archipelago means group of islands. Archipelago means group of island, and they are arranged in an arc manner like this. You can see all the Japanese islands are arranged in this manner. All the Philippines arranged, Indonesian arranged. So this arc, they are also called the island arc system. Means a question could be asked that in what type of collision an island arc system is originated. There might be options of like continental, oceanic, or continental, oceanic. Okay, or they might also give that because of the divergence of the. So the correct answer will be oceanic and oceanic type of collision. Okay. And in this type of collision, where there is a continent and there is oceanic, what will happen here? The same thing. Like you can see that this is the example of North American plate. North American plates, this part, not this part. It means if this is North America, so this western part, where there is Rockies. Okay, this western part of North American plate, and here this is the plate of Pacific plate. It is an oceanic plate. This is continental part. Okay, so when oceanic plate and continental plates are colliding, what will happen? Oceanic plate will go downwards. Okay, like this, oceanic plate is going downwards, and it will, with this subduction, the plate will melt here. This zone is called Benioff zone. where the plate is being melted. Okay, this melting zone is known as Benioff zone. So in Benioff zone, this part of the plate will melt and it will come out in the form of magma, and the magma will rupture this part of the continent and it will come out making this type of volcano here. That is why you can find volcanoes alongside this, alongside this Rockies mountain. There are many volcanoes, series of volcanoes. Okay, because the whole plate is going underneath, and it is being subducted, and after melting, some part of the magma is coming out in the form of volcanoes, making volcanoes. So what will happen here? What are the landforms here in such type of collision? Here the landforms are Himalayas type of high mountains. Okay, here the resultant landforms are like this: Japanese, Indonesian and Philippine islands. One more structure here is found. This trench, such type of trenches. Yeah. So only in such type of subduction conditions, trenches are made. Here also, trenches. Okay. So these are the landforms associated with this type of collision. Okay. And what will happen here? Because this is the continental part and there are more chances of granitic erosion where there is a oceanic area, there is water will erode away this part of the continent, because granite is easily eroded than basalt. It is less dense, it is you can say fragile, so it will be eroded away and there will be deposition of sediments in this part. When these two parts will collide, this sediment will be formed like this fold mountain. Okay, this fold mountain, then this will be very wide. This will also occupy these volcanic areas. Though if there is continuous subduction, volcanoes will come out of this part like this. Here, volcanoes are still active. They are active volcanoes. Yeah, both can be there. There is no limitation in Earth's condition. Okay. Even in the bottom of the Himalayas, there are evidences of volcanism. Why? Yeah, this could be asked in mains. That researches have been done, okay, and studies have been done, and they have found that there are evidences of volcanism. Means magmatic material is there on the floor of the in the first class, in the structure class. I have discussed this, that igneous rock material is the parent, is the basement rock material of the Indian rock system.
But as of it is active region.
Yeah, active region, but where from this magmatic material came, where from this volcanic material came in the bottom of the Himalayas? Actually, there is a theory of Tethys Sea. You know it, Tethys Sea. That in place of Himalayas, there was a sea that was named in such a manner, Tethys Sea. Yeah. So in Himalayan part, actually the thing was like this. The thing was like this. Like this is Indian plate. This is Eurasian plate. Okay. There, this part, and in between them, there was a water body. Previously, okay, and this water body was named Tethys Sea. In geography, it is technically called geosyncline. And this is known as the geosynclinal theory of fold mountains origin. Okay, Means where there are fold mountains, previously there was a geosyncline in all the fold mountains. Either they are Rockies, Andes, or Himalayas. Means in place of there is a statement that geosynclines are the cradles of fold mountains. Geosynclines are the cradles of fold mountains. Cradles, you know, palna. That we call palna, जिसको हम लोग बोलते हैं बच्चा, जिसमें ऐसे सुलाया जाता है. बच्चा होता है ना, तो उसको उसमें बच्चे को ऐसे सुला देते हैं, है ना, सोने के लिए ऐसे झुलाते हैं उसको. ठीक है, that rocks. So means in a way, fold mountains are actually they are you can say they are originated or they are cosseted in those geosynclinal areas. Okay, so initially there was a geosyncline is what? It is like a elongated, shallow, and mobile zone of water, you can say. It is an elongated, a long, shallow, mobile zone of water. Technically, its definition is. Why mobile? Because here the water is not like pond. It is not stagnated. Water is always moving, mobile. And because it is a moving water, means there are sea waves. There are sea waves there. These sea waves, what will do? They will erode away this coastal part. So they will cause coastal erosion. Coastal erosion. Because these are geosynclines. They have mobile zones of water. Mobile zones of water. Okay. So these sea waves, which are originating here in this Tethysty, they will erode away the coastal regions by and by. And what is happening? These two parts of the continents are coming towards each other. Okay, means as soon as a part is in contact with these waves, it is being eroded and the sediment load is being accumulated or deposited here, because this part is not very deep. It is a shallow part. This is the hypothesis of geosynclines. Because they are shallow, means they can be easily filled. They are not like oceans deep. Oceans can never be filled totally, but these zones can be filled because they are not so deep. They are shallow zones of water. So these depositions will fill this zone. Okay, then later on a new part will come into contact with the water. Okay, and more sediments will be deposited here, and the new rocks will be eroded. What will happen? This whole mobile zone of water will be filled with sediments. Will sediment load. Okay. What will happen? This part, actually, this is an example of the mixed plate. Previously, it was not totally continental plate. Means this forward part, this part only was oceanic, because there was a geosyncline, a sea above there. So this was isostatically, this was made up of basalt, and this was less wide and dense, okay, higher density material. So this was basalt here, this was basaltic, this part was granitic, but this part was basaltic. Likewise this, okay. So it might be that one part was more dense and it could have gone deeper in subduction, could have occurred here. Okay, and that time, because of that subduction, because this is a deep area, that would have melt like this, and magma could have come out like this, making some volcanoes and volcanism. That is why we can find the evidences of volcanism in the bottom of the Himalayas. Because later on, what happened? That this whole structure was destroyed. By and by, this whole part, yeah, that subducted, and this whole part, they were fitted together like this. will happen later on? What will happen? This part will be totally subducted and totally destroyed. Okay, and you can say that they were fitted together, jutted together like this. Like this is means after passage of time, Indian plate. Here there might be some evidences of those magma which was here previously. Okay, and now they have been fitted together. And what happened to this sediment? This sediment came up in the form of fold mountains. That is why fold mountains are largely made up of sedimentary rocks. Now you can easily understand, because they are made up of the sedimentary material only. Okay. But there might be some small evidences of igneous, and because there is more amount of pressure conditions there, because of this collision, some of the igneous rocks also have been metamorphosed, and metamorphic rocks could have been formed. Yeah, so there was evidence of volcanism in the earth, means in the history of the Himalayas, origin of the Himalayas. Previously there was volcanism, but later on this whole part was destroyed. Now there was no material of subduction, so no volcanism, no new volcanism, you can say. Understood? So that is why you cannot find volcanoes beneath the Himalayas now. Means active volcanoes. You can only find some of the rocks as evidence of the volcanism. Understood? So this is all about the Himalayan orogeny. This is known as Himalayan orogeny. Orogeny means rising of a mountain. Okay, formation of a mountain. So a question could be asked in prelims or mains that how or in what mechanism the Himalayas were formed. Yeah, means this could look like a very simple question, but its explanation will be different by different students. Okay, one student will explain like this that yeah, there was a convergence between Indian and Eurasian plate and Himalayas originated. But one student like you will explain in this manner that this was the whole mechanism. Okay, so there is that is why there is a difference between the marks. Both the students, they are friends. They have met, and that I have written this, and you will explain that I have written this. There is the difference of marks there. Okay. Only examiner understands that difference. Okay, so we have understood these three types of collisions, boundaries, okay, and the landforms associated with them. The third type of boundary, that is transform boundary. There is no, you can say, creation or destruction of the crust. That is why there is only, you can say, a rift between these two parallel moving plates. There you can see only small amounts of seismicity or earthquakes between them, but no new magma or destruction of crust. Okay, so this is all about the plate tectonic mechanism. Later on in our next class, we will understand how especially the volcanoes are being formed and what are the types of volcanoes, okay, and the smaller features or smaller landforms associated with these volcanoes. Then we will move on to earthquakes and tsunami. Yeah. We'll also do. Okay. Current themes will be associated with these classes. Okay. And later on with your test series. By the next week, you'll be attending the test classes also. Okay. Alongside these classes. Okay. Thank you for today. Nice.
Introducing the Prelims Target course and Prelims Test Series at ProdEgyIAS. Designed for UPSC Prelims 2026, this comprehensive program offers in-depth classes on history, geography, science and tech, environment, polity and governance, and economy. Stay updated with current affairs and sharpen your skills with our Prelims Test Series consisting of 50 full-length tests covering all subjects along with CSAT. Join ProdEgyIAS and stay ahead.